To Step 1, 2015, Question 12. The question tells us the number of casualties arriving at hospital on a given day is X. We're told that X has a Poisson distribution with mean 8, and we're told that that means that the probability that X equals N is equal to e to the minus 8 times by 8 to the N divided by N factorial for integers N from 0 upwards. You may not have seen the Poisson distribution before, but this probability here, the probability that X equals N, totally defines what the distribution is. So this exactly tells us how X is distributed. We're also told that the probability that a casualty requires surgery is 1/4, and we're told that the number of casualties on different days is independent, and also casualties on the same day requiring surgery are independent events. And we're asked, what is the probability that on a day with exactly N casualties, exactly R will need surgery? So in order to work this out, we need to think about what the distribution is. So pause the video now and think, what is the distribution of casualties needing surgery on a given day, given that we already have N casualties? Well, we can see that we have a fixed number of casualties, so a fixed number of trials, N. We have a fixed probability that they'll need surgery, 1/4, and we have that they'll require surgery independently. So our trials, if you want, are independent. So these three criteria tell us that what we're dealing with is a binomial distribution. And indeed, we have N trials, and we want to know when we have, or N casualties, and we want to know when R of them will need surgery. So using the binomial distribution, you can see that this probability is just N choose R times by 1/4, which is our probability, to the R, times by 3/4, because that's 1 minus 1/4, to the N minus R. So that's the probability, and that's the answer to this part of the question. We're now dealing with the same setup, and we've been asked to show that the number of casualties requiring surgery also follows a Poisson distribution, and we've been asked to find its mean. So how can we show that something follows a Poisson distribution? Well, the question's told us that for X's Poisson distribution, it's exactly defined by the probability that X equals N. So if we think of our variable, which is the number of casualties requiring surgery on a day, and we find the probability that that equals some value R, then that will exactly tell us whether or not it's a Poisson distribution, whether it's in this form, and its mean will be some number which takes the place of 8 in this expression. So what have we already done? Well, if we let Y be the variable which is the number of casualties requiring surgery on a given day, then we've already shown that the probability that Y equals R, given that X equals N, where remember X is the number of casualties on that day, is equal to N choose R times 1/4 to the R times by 3/4 to the N minus R. So this is what we've already done, and we want to use this to prove that the number of casualties requiring surgery also follows a Poisson distribution and state its mean. So how can we find the probability that Y equals R, because that's what we're looking for, as we've just deduced? Well, what we can use is the law of total probability, which tells us that the probability that Y is equal to R is the sum over all possible values of X, with the probability that Y equals R given X equals that value times by the probability that X equals that value. And clearly, since Y has to be less than or equal to X, because it's the number of casualties which require surgery, whereas X is the number of casualties, X must be at least R, and it can go all the way up to infinity. So we have the sum from N equals R to infinity, and this probability that Y equals R given X equals N, that's what we found here, so we can rewrite that. And the probability that X equals N, we're told in the question, is e to the minus 8 times by 8 to the N over N factorial. So now we need to try and evaluate this sum, and hopefully it will be something in the form of our Poisson distribution. So how can we do this? Well, we can bring out the terms in the things which are in terms of R, as this is just a sum in terms of N, and we can also rewrite this N choose R as N factorial over R factorial times by N minus R factorial, and that would be a good idea as we see it. We have an N factorial in the denominator over here. So let's do that. Bringing out our e to the minus 8 is clearly that doesn't rely on N. 1/4 to the R and 3/4 to the minus R. And as I said, rewriting that N choose R. Now we can see our N factorial terms cancel out. And we can also group this 3/4 to the N with this 8 to the N, as they both have the same exponent, and 3/4 of 8 is 6. So this will just equal 6 to the N. and we can also bring out this r factorial, as that's not in terms of n. So we'll then be left with e to the minus 8, and then 1/4 to the r times by 3/4 to the minus r. Well, that's just 1/4 to the r divided by 3/4 to the r, so that's 1/3 to the r, divided by the r factorial, and as I said here, 3/4 to the n times by 8 to the n is 6 to the n, and we have our n minus r factorial here. Now, normally we deal with sums that run from 0, and indeed we can see when we plug in the minimum value of n, when n equals r, we have 0 factorial on the bottom here. So perhaps it would be nice to rewrite our basis so that we just have n factorial on the bottom here with n starting from 0. But we need to think about how that changes our 6 to the n term. Well, indeed we can see that that will change our 6 to the n term to a 6 to the n plus r, because here when n is r, the minimum value here will be 6 raised to the power of r. So here when n is 0, the minimum value, we need to have 6 to the r. So we must have 6 to the power of n plus r over n factorial. And now, because this is just a sum in terms of n, we can bring out that factor of 6 to the r. And we can see that here, the sum from n equals 0 to infinity of 6 to the n over n factorial, this we should recognise. And this is actually only very helpful, as it will give us an exponential term, and this will be equal to e to the power of 6. And also this 1/3 to the r here and 6 to the r here, we can group together to be just 2 to the r. It's because 1/3 times by 6 is 2. And e to the 6 multiplied by e to the minus 8 will be e to the minus 2. So we'll be left with e to the minus 2 times by 2 to the r over r factorial. And as we can recall, that's exactly the same form as the probability of x equaling n was, which is the form of our Poisson distribution. So we can see the probability that y equals r is e to the minus 2 times by 2 to the r over r factorial. So that tells us that y is a Poisson distributed variable with mean 2. So we can conclude that, and we are done with this part of the question. We're now given that in some random week, 12 casualties in total will require surgery on Monday and Tuesday. We're therefore asked what is the probability that 8 of these 12 casualties require some surgery on Monday. So in order to attack this part of the question, we're going to need to name some variables. So pause the video and have a think about which variables we're going to need to name. Indeed, we're going to think about the number of people who require surgery on Monday and the number of people who require surgery on Tuesday. So let's name those as M and T, respectively. And we can also recall from what we've done in the previous part of the question that the number of people requiring surgery on a given day has a Poisson distribution with mean 2. And since both of these are just essentially random days, we can see that they'll both be Poisson distributed with mean 2. So these are our variables M and T. So now how can we rewrite the question mathematically in terms of our variables M and T? Well, we're told that the total number that requires surgery on Monday and Tuesday is 12, so we must have M plus T equal 12, and we want to find the probability that 8 casualties require surgery on Monday. So we want to find the probability that M equals 8, given that M plus T is equal to 12. Now, how can we rewrite this if we know how conditional probability works? We know that this is exactly the same as the probability of M equals 8 and M plus T equals 12 divided by the probability that M plus T equals 12. So if we can find the numerator and denominator of this fraction, and then we can put them all together in order to find this probability that we've been asked to find. Okay, so let's have a go at attacking the numerator first. The probability that M equals 8 and M plus T equals 12. Well, if M equals 8, then that tells us also that we must know that T equals 4. So this is just the same as the probability that M equals 8 and T equals 4. You can see that these two things are identical. And now we can use the fact that the number of people requiring surgery on each day is independent, as that will tell us that this is just equal to the probability that M equals 8 times by the probability that T equals 4. And now, can we evaluate these? Well, yes we can, because we know they're both Poisson distributed with mean 2. So let's have a go at evaluating these. We see that they're both equal to, the first one is equal to e to the minus 2 times by 2 to the 8, because that's our 8. 8 is our value of r, as it was in the previous case, divided by 8 factorial, and the probability that t equals 4 is e to the minus 2 times by 2 to the 4 over 4 factorial. So if we bring all of that together, we see that this is e to the minus 4 times by 2 to the 12 divided by 8 factorial and 4 factorial. Now let's try and evaluate this denominator. Pause the video and have a go at doing that for yourself. Indeed, the probability that m plus t is equal to 12, well, we can use the law of total probability to see that this is just the sum of the different values of m and the respective different values of t that will give us the fact that m plus t equals 12. And since they're all greater than or equal to 0, our sum just runs from 0 to 12. And you can see that in every case here we'll have m plus t equals 12. So we now need to simplify what we've got here. How can we do that? Well, again, we can use the independence of our variables m and t to separate this into a product, which is the probability that m equals r times by the probability that t equals 12 minus r. And now we can find these explicitly, because we know they're Poisson distributed with mean 2. So let's write out these respective probabilities explicitly. So what we have is the sum from r equals 0 to 12 of e to the minus 2 over 2 to the r, e to the minus 2 times by 2 to the r divided by r factorial times by e to the minus 2 times by 2 to the 12 minus r divided by 12 minus r factorial. So straight away we can see this 2 to the r and 2 to the minus r will cancel out. And so the only terms that we have in terms of r in this sum is 1 over r factorial and 1 over 12 minus r factorial. So pause the video and see, have a think about what this, these two terms here remind you of. Indeed, what we should see is, relatively quickly, we should see that these two terms are exactly terms in the binomial coefficient 12 choose r. And in order for us to have that coefficient, we'd need to have 12 factorial in the numerator. So let's bring all of these terms outside as a factor, and let's also divide through by 12 to the 12 factorial, so that we can have a 12 factorial in the numerator. So do something like this. And now we can see that what we have here is exactly 12 choose r, and this is all fine because these are just numbers. They don't depend on the value of r, so it doesn't change our sum at all doing this. So now we can just rewrite this as 12 choose r, and now we're just left with this factor times by the sum from r equals 0 to 12 of 12 choose r, which you should recall just evaluates to 2 to the power of 12, and therefore we can group that with our other 2 to the 12 term to see that we have e to the minus 4 times by 2 to the 24 divided by 12 factorial. So we've now found both the numerator and denominator in the fraction we want to evaluate, so all we've got left to do is to divide this by this, and we'll find that our probability. Okay, so we've deduced that the probability that the number of people who require surgery on Monday is 8, given that the number of people who require surgery on Monday and Tuesday altogether is 12, is equal to e to the minus 4 times by 2 to the 12 divided by 8 factorial times by 4 factorial, all divided by e to the minus 4 times by 2 to the 24 over 12 factorial. So pause the video now and see how far you can simplify this, as we want to write this probability in the most simple terms possible. Indeed, to divide one fraction by the other, we just flip the second fraction and multiply them together. So we see that this is equal to e to the minus 4 times by 2 to the 12 times by 12 factorial in the numerator, divided by e to the minus 4 times by 2 to the 24 times by 8 factorial times by 4 factorial in the denominator. And straight away we can see that this e to the minus 4 term in the numerator and denominator will cancel out, and that we have loads of powers of 2 in the numerator and denominator, so cancelling out a factor of 2 to the 12 from both leaves us just with a factor of 2 to the 12 in the denominator. And the other terms that we have in this fraction are all factorials. So if we just think about 12 factorial divided by 8 factorial, well, all of the terms in the 8 factorial will cancel out with terms in the 12 factorial and just leave us with the product 12 times 11 times 10 times 9. And we can rewrite this 4 factorial as 4 times 3 times 2. So we'll be left with this. And straight away we see that 12 will cancel out with 4 times 3. So now we just have 11 times 10 times 9 in our numerator and loads of factors of 2 in our denominator. So there's only one factor of 2 in the numerator in this 10, so we can cancel that out with this 2, and that will just leave us with 11 times 5 times 9 in the numerator and 2 to the 12 in the denominator. And we can see 11 times 5 times 9 evaluates to 495, and 2 to the 12 is equal to 4096. So that is the final answer, and that's our probability.